are vision-based systems. Vision-based are one example of basically a general category that's motion detection. Because most of the vision-based systems somehow detect motion or some way of movement in the objects, although it doesn't have to be like that. So as opposed to typical GUIs, when you have your desktop and you use usually mouse and keyboard to interact with it, in vision-based system, it's your body movement that's somehow detected by cameras. I don't want to get into detail of it. This again, as you see in this slide, the actual research on vision-based interfaces started again in early 70s. But even now, we don't have a lot of them, and I'll talk about some of the recent examples. How does it exactly work? At least in theory, it's not that complex. If you have a camera that's looking at you as the user, you're basically receiving a series of frames of images. And these images are usually consisting of two different types of things, a background and a foreground object. So if you look at this example here, it kind of shows you that each pixel on the image that you're receiving either belongs to the background or to the foreground. In the simplest possible way, the foreground and background pixels have different colors. So your software can automatically go through these pixels and detect where is it that the color is changing. As you can see on that raster line, in the simplest possible case, you basically on each line you get 2 points where the color is changing, and these are the two sides of the foreground object. Detecting all of these points, you'll basically have the boundary of your object. Now that you have the boundary, mathematically you can decide the shape, you can decide on the location, and also when you have a series of frames, you can decide on how the object is moving and how its shape is changing. Of course, I'm really oversimplifying the process, but that's kind of the idea behind it. You can imagine that it can actually get a lot more complicated than this, because foreground and background objects don't necessarily have this simple black and white situation, and you can have more than one foreground object, they can overlap and all those kind of problems. But that's the general idea. So now instead of having a mouse and a keyboard, you basically move and the system detects, for example, do something in your computer, open a file or something. For example, your movement can mean something to the game. I don't want to get into details of vision-based user interfaces, but we usually talk about two things, sometimes referred to as verbs and nouns, or the actions that the system performs and the things that the system is dealing with. Actions are obviously things like detecting objects or recognizing objects or tracking objects, which are a completely different thing. When we talk about detecting, that means you basically say that in a certain region of your image, there is an object. So you're basically detecting that boundary. Tracking means that if you have a region in image 1 and another region in image 2, you basically understand that this region in image 2 is the same as the first one, which now has moved. So you basically track the object. And finally, recognition means that you decide which object that is. So again, as I said, I don't want to get into detail of all of these things. Here are some examples of things that for example, detecting faces. These days, you see a lot of software that can actually do that. Even your cameras have simple face recognition, face detection facility in it. So basically, you look for certain, and if you find that pattern, you recognize that area as a face. Of the nouns or things that we are dealing with, which can, again, as I said, I don't want to get into detail of this, but the reason that I mentioned vision state of the art in interactive systems, especially in the Game Act or Project NATO, which is Microsoft's solution to basically game mouse keyboard thing. You basically provide input to your game through movement of your patient, but instead of having just body movement, you actually have a device that, and more, I would say, doable version of the same one. So in the first, the Microsoft version, yourself and the computer tracks you. In the second one, you actually need to have a controller detecting that little colored ball that's on top of your controller is a lot easier than some of the tools that are very famous for doing called OpenCV. If you're a programmer, you can use OpenCV to write your own, basically, computer vision algorithms and program and write your own game that's vision based. And I don't want to get into detail of that. And there are some books about it that also. But as I said, using computer vision, using cameras to detect motion kind of is an example of general category of detecting motions. But detecting motion doesn't have to be done through simple camera and computer vision. You can have a whole bunch of other methods of doing the same thing. Because we don't have a lot of time, I'm going to go quickly over these, but I'm very quickly mention that other typical examples of detecting motion are using different type of sensors. For example, in a typical